Cute. We'll never know.
Okay? What we're doing today may be, it's very simple, but if you can't get, if you do not know this lesson, you will be so lost later on, because we're going to start building and we're going to start building fast. Okay? So it says there are three broad classes of elements on the periodic table. We have metals, we have nonmetals, we have metalloids. Okay? Metals have a specific property, specific properties. How do you think nonmetals relate to the properties of metals?
They don't have them.
They're opposite. And where do you think metalloids fall in? In between. So metals have certain properties, nonmetals have the opposite properties of metals, or very, very different, and metalloids are somewhere in between the metals and the nonmetals. So let me give you a tangible example of this. Metals are great conductors of electricity and heat. Nonmetals are awful conductors of electricity and heat. And metalloids are in between. Okay conductors. You ever heard of a semiconductor?
Yes.
That's what a metalloid is. Not a great conductor, but not an awful conductor. And you can understand there's probably some uses where you would want things to maybe conduct a little bit of electricity, but not a lot of electricity. Okay? Pretty sure a lot of your keyboards and things like that have semiconductors in them. Okay? So that's sensitive to its point, but not too much. All right, metals. So we're going to talk about where the metals are located on the periodic table so that we can just look up the periodic table and identify where the metals are. So here you go. This is how we identify them. Here's an important property about them. And we're going to, the most important thing I want to grasp here is being able to look at the periodic table, and based on where it's located on the periodic table, I want us to be able to say that's a metal. Okay. Believe it or not, most of the elements on the periodic table have metallic or metal-like properties. Okay? And you can tell, after today, you should be able to, if I just point at an element, you should be able to tell me, is that a metal, non-metal, or metalloid? And we'll get to that. Okay? Here's how you identify if it is a metal. There are a few exceptions, but here's how we do it. Does everyone see this right here? What does that look like? Stairs, doesn't it? Okay? Let's call the stair step line. It's there for a reason. Okay, so here's how we locate the metals. Metals will be to the left of the staircase, but not adjacent. Adjacent means along a side. So, I'm going to say this is along a side, so we would say this isn't a metal. This is one of the exceptions, because aluminum is very much a metal. Okay, so aluminum is one of the exceptions. Okay, germanium. Notice how it's along a side. This is not a metal. What about gallium? It is a metal, because it's not adjacent. It's on a corner. It's not along a side. Okay, so this would normally not be a metal, but there is an exception. This is a metal. This is not a metal. This is a This is not a metal because it is adjacent or along the side of the stair step. Okay? This metal. Okay, and this one they actually say is kind of, I've heard metal, I've heard not a metal, but we won't really ever deal with poloniums and we won't have to worry about it. Okay? There is one other exception to being left and not adjacent, making it a metal. This loner up here. This guy is not a metal. Okay? It has more non-metal-like properties, and one of them being gas, yes. Okay? So hydrogen is actually a non-metal. Okay, so there are two exceptions you need to remember for this. Left of the stair step and not adjacent are typically going to be metals. Here we have an adjacent guy that is a metal. That's exception one. Here we have a guy that's left of the stair step and it's not a metal. What is it? It's hydrogen, but what did I say it was? It's a non-metal. Okay? Now, probably the most important thing about metals is that they tend to easily give up their electrons readily. Probably makes sense why they conduct electricity very well if they readily are just passing on electrons like crazy. What do you think? Do you guys know electricity is just moving electrons? When you turn on a light, all you're doing is having electrons move through your wire to your light bulb, and there's so much resistance in the filament of your light bulb that as electrons pass through the filament, it's like a whole bunch of friction, and therefore it lights up and gives off a whole lot of energy. Do you guys know that all light bulbs are, or what causes light, is a transfer of electrical energy due to friction in the form of light and heat? Interesting. Yeah.
You get shocked, you get run over by a bunch of electrons.
That's a little bit different. I'd say large transfer of energy from your body to the ground, which causes some problems. Okay, talk about the non-metals here. This periodic table is arranged pretty sweetly. You know a few things, you just look at the periodic table, it tells you a lot of information, doesn't it? Now, I could look up here at chlorine, and they could tell me, I can know how many electrons and protons it has, how? By atomic number. I can tell you it's a non-metal based on its location. I can also tell you it's a gas at room temperature based on its color. Wow. And that's only a few things that I can tell you. I can also tell you it's in the third energy level. I can also tell you it has 7 valence electrons. Right? There's a lot of things that I can tell you. I can tell you that it has a certain mass. Just to name a few. I can tell you that it gains 1 electron pretty readily. I can tell you a lot of information just by looking at a particular element on a periodic table. We've just scratched the surface on some of these things. Okay? But we need to start being able to pick up on this. Here's why this is important. Now what I'm about to say is going to make absolutely no sense to you, but I'm just going to show you that this is vital for what we're going to do in the future. Eventually, we're going to talk about the 3 types of bonding and how they bond and why they bond. Okay? Eventually, we're going to start writing formulas of compounds and naming formulas of compounds. In order to write formulas or name formulas, you have to know if it's a metal or a non-metal that's bonding. Because that will tell you what type of bond will form and how you write it. Then, we'll take those compounds that we have just written and we have just named, and we'll write an equation with them and show a chemical equation. Then, we'll take that chemical equation and we'll balance it to show that the first law of thermodynamics holds true. Then when we take chemistry, we'll do the theoretical mathematical stoichiometry of that equation to tell you exactly how much product will be produced and how much reactants will react to produce it. All based on knowing metals, nonmetals, and metalloids. Can't do any of that stuff without knowing this. Cool? Now, is this hard? No. So it's a whole bunch. Chemistry is a whole bunch of easy things that build upon themselves that become very difficult if you forget one of the easy things. Okay? So, nonmetals. Right up the stair step, but still not what? Adjacent. So what do you think the metalloids are? The ones adjacent. Okay? So boron, is that a nonmetal?
No.
No, because it's adjacent. How about carbon?
Yeah.
Yes, it's on a corner. It's not adjacent, so it's going to be a nonmetal. Silicon?
No.
No. Phosphorus?
Yes.
Are you seeing the trend here?
Yeah.
Okay, I think we're good. Now, what's interesting, didn't I say that metals and nonmetals have opposite properties or very different properties? Metals tend to gain electrons. What do nonmetals tend to do? Sorry. Metals tend to lose electrons. What do nonmetals tend to do?
Gain.
Or they will share them, but we'll talk about that later. And then your metalloid. Sorry. Excuse me.
Oh.
You said like
My dad had out like forever.
Why would he keep it in his mouth forever and then swallow it later?
That's my sister.
He purposely tries to discuss his daughter.
yeah, my dad. Disgusting.
Walk around with his shirt off, chest hair everywhere.
Not do that. He is growing a beard. Have you seen him lately? My dad?
I don't know. I feel like I have. I don't feel like it's very long. Man. Go, Randy, go. Just grow it out. No shave November, baby.
That's Santa's beard on. He's starting early. It's not yet. It's not even November yet. I just said yeah. He's starting early.
Yes, sir. 1.
No, like, that, hey,
So it's like.
Okay, so I've already said metals have opposite properties of nonmetals. Okay, metals tend to give electrons, nonmetals tend to take or share. Then we got metalloids, which are somewhere in between. Okay? So metalloids have properties in between metals and nonmetals. An example of this is what I stated earlier. They're semiconductors. Okay, they're not great conductors of electricity, but they're not awful conductors of electricity. And there are some very, very practical reasons or applications for that. And I think you guys probably have already figured this out, but left of the stair step, not adjacent, are what? Metals. Right of the stair step, but not adjacent, are nonmetals. And the ones that are adjacent are called metalloids. There are 2 exceptions. What are they?
Aluminum.
Aluminum, even though it's in the metalloid section, it is still a what? Hydrogen, even though it's in the metal section, it is a nonmetal. It has non-metal properties. Okay? Hydrogen is goofy because it has one valence electron, like group 1, but it only needs one valence electron to be stable, like group 17. That's why typically it's non-metal properties. Because what determines the properties? Ah, funny how that works. These are the vertical columns, element families. Okay, we're still talking about how things are arranged in the periodic table, because we said the periodic table has periodic properties. What does that mean? What does periodic mean? Didn't we talk about this yesterday? Recurring, repeatable? Okay? So, groups and families are part of the repeatable or reoccurring properties. Now, we've already talked about this, but I'm now just giving you the name of them. Okay? Didn't we identify number of valence electrons by the vertical column that they were in? Okay? Those vertical columns can be called one of 2 names. They can be called group 1, or I could call it family 1. Why do you think they call it families?
Because they share the same traits.
Yeah, because typically people in the same family have similar characteristics, traits, and properties. And since they're in the same vertical column, they have the same number of valence electrons. Isn't that what valence electrons determine? Similar chemical and physical properties? Yeah? Okay? Very important here. Just some vocab names here. So if I ask you, bromine, what family is it in, or what group is it in? What would you say? Group 17? How many valence electrons does it have? 7. Okay? If I said calcium, what group is it in? Group 2, family 2, how many valence electrons does it have? 2. Okay. What if I said argon? What group is it in? 18. How many valence electrons does it have? 8. Someone said 18. Did you say 18? Okay. Alright? Very important. Now all of those guys in group 18 have 8 valence electrons. They're all in the same family because of it. Alright? So let's just look here. You don't have to put this in. Beryllium, how many valence or outer energy level electrons does it have? 2. Everyone see it? Oh, magnesium? 2. How about calcium?
2.
We're seeing a trend here. Now each of them is gaining an energy level, because if you remember as we go down the periodic table, your energy levels get higher. Strontium?
2.
Barium?
2.
Wow, so I bet you if we counted all those little dots, do you think we would get 88 electrons? Sure hope so.
Let's count them. Well, I'm not counting those.
Not counting them, sorry.
Wait, just look at the periodic table. 88.
Okay, now I want you guys to put all of these in your notes. I want you to tell me, or right next to them, if it's a metal, non-metal, or metalloid. What?
I already wrote them all down.
All of them?
Yeah.
Well, almost all of them. I didn't count like the post-transition metals because I didn't see that. Yeah.
Okay, I want you to put this in your notes. I want you to put oxygen in your notes, and I want you to say, what is it? Metal, non-metal, metalloid. Lithium, metal, non-metal, metalloid.
I'll put a number.
Guys, I don't think this is overly difficult, but don't hurt yourself by not spending a little bit of time thinking about this, because we will use it a lot in the future.
Ooh.
We got location on the periodic table tells you metal, non-metal, metalloid. We've got a group tells you how many valence electrons it has. We know the colors tell us something. Eventually we'll talk about how the horizontal rows tell us something. We've already talked about it a little bit.
Yeah, I guess that's maybe.
Yep. Getting close to being done here? Wilson, got her done? James, still working? Which one are you on? Okay. Probably can't find them, can you? Guess hardest part is finding where they are?
Yes.
Maybe I should put their atomic numbers. I'll start with silicon, atomic number 14, aluminum 13, iron 25,
26.
selenium.
Iron 26.
Is it? Oh, it is. 26.
Gallium's 31.
34.
Gallium's 31.
There you go.
Hydrogen's 1.
So we can go back and we can do isotope notation for all these guys. We can identify protons, electrons, and neutrons. I mean, that stuff isn't going away. Okay. do not short-term memory cram. It will hurt you in the future. Okay? That's why those physics students, when they leave, and they all belly aching over being so hard because they've got bad study habits. Okay? Alright, here we go. Let's start with Carly. Oxygen. What is it?
Metal.
What?
Non-metal.
Okay. Moira, William.
Metal.
Shade, hydrogen.
Non-metal.
Ooh, tricky one. One of the exceptions. Derek, silicon.
No.
What?
It's the third one. I don't know. The metal.
Is it a metalloid? It is a metalloid.
Metalloid. Metalloid.
Can't abbreviate that.
You spelled it right.
I spelled it wrong?
Yeah.
We'll just do
O-I.
What?
O-I. Not I-O. O-I.
Metalloid.
It's metalloid.
Okay.
It's like
Alright.
metalloid. It's like my name.
Everett, aluminum.
That's
What?
metalloid.
I still.
Metalloid.
No.
That's the exception.
It is the exception to the location. Remember? Last time I checked, you pull out aluminum foil, very much metal-like properties, huh? Shiny and conduct electricity. You won't want to throw that in your microwave anytime soon. Sydney, iron.
He put oil in a microwave. It was a Starburst wrapper. How was I supposed to know it was metal?
Starburst wrappers are made out of metal?
Yes, apparently. I put it in the microwave and it.
You put a Starburst in a microwave.
Hey, don't leave. Selenium is what?
That was
Apparently
it's
it's
flammable. This is like some
Gallium?
metal.
Stop, I want to make sure we got through everything. I don't think we did.
No, you were
Alright, quickly.
Balance electrons.
This should be stuff we already remember. Let's just review. The vertical columns tell us what valence electrons they have. Group 1 has 1, group 2 has 2, group 13 has 3, group 14 has 4. So I will call on you, you tell me. We're not going to have you put them in the notes. We're just going to call on you. Mari, oxygen.
What?
How many valence electrons?
Mars was blood.
What do you see?
6.
Okay, yeah.
Evan, shut up.
Yeah, what, yeah.
How many valence electrons does it have?
Everett just said it.
8?
Everett, what did you say?
6.
6.
Yeah, 6.
Come on.
Okay, Ethan, lithium.
Lithium has, oh no, 1.
Beryllium, Carly. Far left. Top. Silicon, not leave. Stevie, silicon.
4.
Shane, aluminum.
3.
Moira, argon.
8.
Derek, chlorine, far right. Rose, gallium. Near the middle. How many?
Yes.
I think it's 3.
Oh yeah.
Alright.
5.
Vertical column.
I gotta cook my hot
Vertical
dog.
column. Mari.
I'm so hungry.
He's not listening to what bar.
Steven, don't we have basketball meeting today?
No, like,
Testing.
so there's orange. Maybe just don't. Figure out. Somebody said like, that's why I did that. And I was figure out where I got it. And I'm like, drop it, guys. Just like,
Oh, you mean how it really
oh,
just how they feel.
or my brain is doing it. It's doing
I don't know why they just don't go 4D. I'm not sure.
What's the side?
These ones? These are energy levels. So if we're talking about beryllium, it's outer electrons in the second energy level. We're talking about strontium, its outer electrons are in the 5th energy level. We'll probably talk about that. I hope that wasn't on the next slide. So, sweet.
I'm trying to think logically in my brain.
No, homework's
Yeah,
tomorrow.
it's not a logical It's not a logical
No,
explanation.
I'm trying to remember everything and do it in my head, and it's just like there's no paper in front of me.
Oh,
Let's
sure.
write it down.
Sure. And of course.